Hello and welcome, ladies and gentlemen, boys and girls, scientists of all ages, to another exciting episode of Echo Live. We're broadcasting from the Echo Live studio here in beautiful Midtown Detroit at the Michigan Science Center, where we put you at the center of science. Well, today, my name is Christian, and today we're going to explore another topic. You may have seen me on here before where I did a presentation on something called paper instruments. And that's what we're going to talk about today, paper instruments. And when we describe these instruments, you think we're talking about instruments that you play or instruments that you like musical instruments? Well, not exactly. These instruments are instruments that scientists use to measure and model the universe. So when you think about the concept of an instrument, what we're really talking about is an instrument that we use to extend the senses. And to extend the senses, we can use things like microscopes to help us see things that are really small, or like telescopes to see things like M31, the Andromeda Galaxy, which is very far away. As a matter of fact, it's 2.2 million light years away. That's very far away, but you can see it in the night sky. The instruments that we're going to make, these paper instruments, are things that you can use with just paper, some scissors, and some devices. So we're going to do one. Last time we did a star clock to learn how to tell the time by the stars. But this week, we're going to learn about how to track the moon. We're going to create a moon calendar and a moon dial. You guys ready to dig in on that? But first, we need just a little information. But before we go to this information on this, I want to just remind you, go ahead and check in if you haven't already, and check into our chat feature and tell us where you're from and maybe what grade level you're in. And if you have any questions or comments, you can just toss them in the chat as well as we go through the process. All right, so let's continue on, and let's start with our PowerPoint as we talk a little bit about the fun facts on the moon. So I'm going to give you some quick facts about the moon, things that you're familiar with, and then we're going to go through some cycles of time and space, the phases of the moon, a moon chart, a calendar, and then we're going to put all the pieces together in our paper instrument, which is our moon calendar, moon dial, and then we're going to go to Stellarium. This is the free planetarium software online that you can do on the web, on your computer or mobile device. It's a lot of fun. And we're going to use Stellarium to try to practice with our moon dial. Sounds like a plan? All right, so let's jump into our first slide here. How many of you have seen the moon at night? I know I have. I see the moon a lot, and sometimes I wonder which phase it is. And so we're going to learn all about the phases during this process. And normally when you see images, artistic images, you'll see the moon depicted at night. But guess what? You can also catch the moon during the daytime. So this slide gives you an idea of what that looks like when you look at the moon in the day. This is what people normally call a half moon, but it's really more of a first quarter moon. And you can tell by the side that's lighter, the direction of the sun. So which direction do you think the sun is in from here? Is it to the right of the screen, the upper right, or the lower left? Where would we see the sun and why? Okay, we'll see if you have some thoughts about that question as we go through these. You know, incidentally, sometimes you see the moon and the clouds will come in front of the moon, and that just tells you, just even the ancients knew that the moon was further away than the clouds. Very often you'll see the moon close to the horizon during its rising time, and it always looks bigger, doesn't it? But that's an optical illusion because the moon is now in reference to things like trees or buildings or churches or whatever might be around. That gives you a perspective on that. So as you're answering this question, the direction of the sun, just from this image, what would you think it might be? Well, take a look at the lighter side of the moon is on the right, and that illumination is not coming from the moon itself. It's light that is reflected off of the surface of the moon, which means the sun would be to the upper right of this image. And that's how you can always tell where the sun is, just by looking at the moon. Even when the sun is below the horizon, you can see a crescent phase or even a half moon or first quarter moon phase like this that points to the direction of the sun. All right, let's keep going. More moon facts. What about craters? Craters are probably the most exciting thing about the moon. And I think our resident astronomer, Paulette, had done a previous Echo Live where she was looking at the craters and showing you how to make craters out of flour and a little bit, you put flour in a pan and you put maybe a little bit of chocolate powder over the top of it, and you can drop marbles and things and make a lot of cruel craters. So if you ever got to have a pair of binoculars like these, I invite you to go outside. Don't use them to look at the sun. The sun is much too bright, and that would be unsafe. But you can use binoculars or other things like telescopes to look at the moon. And when you find it in the sky, boy, you can see thousands, countless amounts of craters on the surface. It's actually beautiful. Let's take another look at the slide. Another fun fact. All right, how about this? What about the size and the distance? This is the part that is really challenging. As a matter of fact, in almost every image that you see in astronomy, you always see something in parentheses that says image not to scale or not drawn to scale. That's because it's really hard to fit space into a frame. Space is vast. There's lots of cool things that are out there, and many of them are very far away. Luckily, they're bright enough for us to see them here on Earth. So when you see this slide, imagine for a moment, you've got two pieces of fruit, one in one hand and one in the other. And the grapefruit would represent the size of the Earth. So if the Earth is the size of a grapefruit, how large is the moon? The moon is about a quarter of the size of the Earth, but its distance is actually 30 Earth diameters away. So in this case, it would be almost like holding a grapefruit in one hand and handing it to a friend, the plum, and having them walk 10 feet away. That would be how far away the moon is from the Earth. It's 238,000 miles away from Earth. So if you have a car and you've driven 230, if you got it, that's a nice car. If you've got 238,000 miles on it, but it's possible. And that would be almost like driving to the moon. That's the average distance between the Earth and the moon. So let's take a look at another slide. Another cool fact. The moon revolves. That means it goes around the Earth. So this is looking at the Earth from the northern hemisphere down on the polar ice caps. You could watch the moon rotate around in a counterclockwise direction. That means like watching the hands on the dial of a clock go backwards. Isn't that cool? Let's look at another fact. Another fun fact is this. Not only does it go around in this counterclockwise direction, but the face of the moon that we see is the same face regardless of the phase because they're tidally locked. That means that the revolution of the moon, the orbit around the moon, the orbit of the moon around the Earth, and it spins on its axis just like the Earth does, but it spins on the same time frame or the same cycle that it goes around. So we always end up seeing the same side of the moon. You want to take a look at how this might work? Let's try this. Let's start with the Earth. Here's the Earth. That's a good catch. I should play for the Detroit Lions. All right. So here's our Earth here. Our precious little Earth. I'm going to put it down because it's going to represent our reference point. And then now let's take a look at the moon. The moon has a face already on here. Isn't that cute? Look at the moon. So I'm going to have the moon go around the Earth. And again, I'm looking down at the North Pole from space. I'm outside of the frame. And I'm watching this moon go around. Does it go around like this? Just like that? Well, if it did, it means that the moon would not be rotating at all. Let's take another look at that. Is the moon spinning around? It's not spinning. This would be spinning. It's just going around or revolving. The spin is called a rotation. And it just so happens if these are synced up like they are with the Earth and its moon, a natural satellite of the Earth, it would actually go around kind of like this. You see that? And you're going to be representing the sun. So it's almost like I'm putting the sun and giving it to you. Where's my sun? Face of the sun. There it is. The face of the sun. And I'm tossing it to you, to your living room where you're watching this show. And you would watch the moon go around just like this. So it is spinning on its axis, but it's doing it in a way that's synced. So we always see the same side or the face of the moon. Isn't that cool? All right. So let's keep going. Let's go back to our slides for a second. Because now we can see a little bit more about how this the moon affects the Earth. As it goes around, the moon has gravity too. It's not as strong as the Earth. So the moon remains locked in the Earth's orbit. It is in the Earth's orbit actually, but it orbits around the Earth as the Earth is orbiting or revolving around the sun. But the tides are created by the moon's pull. Actually, the sun creates tides as well. It's just not as noticeable. So if you've ever been to the ocean and you watch the tide come in, where you've built a sandcastle and all of a sudden the water continues to just lap up closer and closer to your castle until your castle is washed away and underwater, that would be representative of the tides. Now, what else is cool is eclipses. I love eclipses. And if you've ever seen an eclipse, either a solar eclipse, a lunar eclipse, a total solar eclipse, a partial lunar eclipse, it's all very complicated because we're thinking about this motion almost in 4 dimensions, right? 3 dimensions of space and a dimension of time as we cycle through the moon's orbit or its particular revolution around the Earth. So here at the top, you can see how a solar eclipse is formed when it's lined up. And so you can see the moon, the sun, and the Earth all lined up with the moon in between. And when it blocks out the light of the sun on Earth, a shadow is cast on the surface of the Earth, the penumbra and umbra being the darkest part of the shadow, and that creates a solar eclipse. A total solar eclipse like we had in 2017 is, if you ever had a chance to see that, it was outstanding. If, as a matter of fact, in the chat feature, if you had a chance to see the total solar eclipse in 2017, I would love to know what your thoughts were. Like, put that down if you had a chance to see it, because there's another one coming up in a few years. You get a chance to see that as well. But look on the far side and still that image at the top. You can see the lunar eclipse. And all the lunar eclipse is the revolution. Again, the moon going through its orbit passes into the shadow that's cast by the Earth. And that can create a total lunar eclipse. All right, so we'll keep going on with our slides with more moon facts. The moon's orbit is in an oval shape. It's not really circular. So sometimes the moon is at apogee, which means it's closer to the Earth, and you can see it coming closer. And sometimes the moon is further away. This is a time-lapse image of several pictures taken of the moon, and you can see it almost wobbling because of the direction of the rising and setting, and also going through the phases. And it's also sometimes closer and sometimes far away. These are called the librations of the moon. Now, quick fact, take a look at the edges of the moon to the right or the left. Can you see more of the surface? You would think that we would only see 50% or half of the surface of the moon, but we actually can see more than half of the surface, more than 50%, because of the angles on Earth and how it moves through the sky during these librations. So we'll keep on going. Another cool fun fact. Finally, well, this happens to be the only celestial object that we visited. I mean, like, we actually went there, right, in 1969 for the first Apollo mission. This depicts Apollo 15, Jim Irwin, astronaut and Air Force test pilot, and University of Michigan grad Jim Irwin, actually jumping up and down on the moon in the 1/6 gravity. It's 1/6 of Earth's gravity. You can even see the rover. I believe parts of the rover were built by General Motors, actually. And you can see it just right there. So if you think of a car on the moon, well, this was the car on the moon. It was called the lunar rover. All right, let's keep going with our slides. Finally, these are the phases of the moon. So I've got a question for you. Which phase is your favorite phase? Which might be, put that in the chat. What might be your favorite phase of the moon? Okay, I'm going to pick a phase of the moon that's my favorite phase. And it's the one that you really can't see in this image. It's called the new moon. And that's really close to the phase that we're in now. New moon is the one that's closest to the sun. And the reason why we can't see it is the sun is illuminating the far side of the moon. So we can't see any of the illuminated part. That's why trying to find the new moon is so difficult. As a matter of fact, don't try to find the new moon because it's so close to the sun, it could be dangerous to look at. But the phase that we're familiar with, that's that sliver right there at the top, the waxing crescent, just right after the new moon phase, you're going to be able to go outside. And if it's clear, weather permitting, you'll be able to see the waxing crescent begin to form shortly after sunset. And you can watch this moon's motion through the sky, kind of moves backwards through the sky as it goes through its period. All right. So finally, if you've got your question down on the, or answers to the question on what your favorite phase, I said mine was the new moon. And you know why? Because I don't like the filling of the cookie. So here you can imagine these Oreo cookies here. This is a classic activity that maybe you did in your classroom with your teacher, in which you use the filling, the creamy filling, to be able to show the different phases. So the new moon is on the right, the full moon is on the left, the Earth is in the middle, the sun is also to the right. And so we're close to that new moon phase. And if you do this activity at home, it's really easy. And you're probably thinking, well, how do I glue this to the page? Well, and we'll have these links in our post so you can go to them and try it yourself. But I actually use frosting. I use the frosting to sort of glue the cookies down on the sheet, and that creates a fantastic phase of the moon graphic that you can even eat. So wonderful. All right, let's keep going. Now, you've always seen this classic diagram and exercise. And I'm just going to show this for a second. It's also a GIF. And you can watch it go through the phases. So this woman is holding the moon at arm's length, and she's watching the phases from the perspective of the Earth. So take a look at the top as we go through and cycle through this. You can see the full moon, waning gibbous, last quarter, waning crescent, new moon. That's kind of where we are. And so as we go back again, you'll see it go to new moon, and these will be the phases that we will see. A new moon, a waxing crescent, first quarter, waxing gibbous to the full moon. So let's keep going on just a couple more slides. You've all seen me present this before, this wonderful book by Jay Ryan, Cycles of Time and Space. So we go through the day and night cycles. You see half of the Earth as it spins around is in day, the other half is in night. Let's go to another one. You can see the moon's phase in the lunar month beginning with new moon, as we just talked about that's happening right now. Next slide takes us to further out as the moon begins to grow. And then finally, you start to see the moon rising from the horizon in this next slide, where you have the moon's sort of crescent shape each day. And that sliver just gets bigger and bigger and bigger and bigger. Okay, so now let's switch for a second because I want to show you how to track this. So if we come out of our PowerPoint for a moment, you'll get a chance to see something called a moon phase calendar. And this is a tool, which is our paper instrument, that I found on NASA JPL's website. And the link will be put in our post so that you can get to it and see it. And it's a nice little calendar/computer that you can build. And so to get the tools that you need, you'll just need a pair of scissors like these, a hole punch like this, brass fasteners, which are always good to have when you're doing crafts. They just look like this, these little things. And what else do we have? And of course, some tape, some Scotch tape, and the printout. Now, there's several parts of this, and I'm going to hold them out. The one that I showed you here is sort of the finished, completed model. If you have a color printer, you can print it out like this, and it will show you the different pieces. And actually, in this graphic here that we'll show on the PowerPoint, you can see all of the different pieces, and you can see all of the different materials that you will need to actually do this, including a pencil. And you can, if you do the one that's not colored in or you don't have a color printer, you can actually use crayons to color something. So on the left, you'll see the calendar itself. And this is for 2020. It has all of the moon phases listed out and their dates. The part in the middle is the face of the dial, which shows you the orientation. And then the moon phases, the kind of like if we were to put this with using the Oreo cookies, you would have the moon phase dial to the right. So as you cut this out, and I'll give you an example. So let's go back out to the screen here. All you have to do is be a little bit gentle in your work here is to take your scissors, and if you're still new with scissors, you can get some snub nose scissors to work through, and you'll just cut out the face of the dial, just like this. And as you gently cut around, you'll get a chance to remove that face of the dial, and then you would cut out the face of the moon. There we go, sort of the computer or the clock part of it, and you gently cut these pieces out to make little holes that you can use as well. And then finally, it will be this part that you cut out, which is the actual moon dial itself, which is easy to cut out just like so. All right, so once you have these pieces out together, and I'm going to use the one here that I have this assembled, you'll see all the things we talked about, from a calendar of the moon, to the moon dial itself, like the Oreo cookies, with all the different phases from new moon to full moon, as well as the face of the dial itself. And if I put it under here, let's take a closer look. So on the document camera, you can see these. And as you get a little bit closer, you can start to see the dates. So the dates that we would use now are in August, and we just look for the new moon phase. So as you can see here, August 18th, which was yesterday, would represent the new moon phase. And so I would just be thinking about lining up the new moon with that particular phase, and that will help me see the calendar. So you can look at what the phase of the moon was even on your birthday. So my birthday is in October, so I would look at the phases in October to be able to see that just a little bit better, okay? So now as we put these together and you cut them out and you tape the pieces, you can actually create your own moon calendar. So I'm going to start with the calendar itself, and then underneath it, I would put this moon dial right here on top. You can see I made some punches in there for the holes. And then I would put the face of the dial on the top and the brad in the middle. So let me go ahead and put the brass fastener in the middle, if I can make this work. Sometimes you may have to do them one at a time to make sure they go through the holes correctly. And then when you do, you will have an amazing, amazing paper instrument that you will just gently fasten on the back. And now you can see it moving around. You can move the calendar like so. You can move these here, which are the different phases. This is a waxing crescent phase, a first quarter phase, a full moon phase. So I'm going to go to the phase that we're in now, third quarter. So if you want to use this, and especially if you printed out the really cool one here that says moon phases from NASA JPL, you can go to this particular date in August. So let's more away through April, May, June, July, and August. We will look for August 18th and 19th. And all we will do is set this up so that our phase matches the phase on the calendar, and we can do lots of other cool things, like knowing when that particular phase will rise and when it will set. So if the new moon phase is close to the sun, then the rising time of the new moon would be with the sun at 6 a.m. and it will set at 6 p.m. If we go to the first quarter phase, the one that we saw in the daytime, you can see that it rises in the east, just like the stars and the planets do, and it rises in the east at 12 noon, and it sets at 12 midnight. So you can see how this is not only just a calendar and not only just a clock with the phases, but it's like a moon computer. You can compute the times based on the phase that you see in the nighttime sky. Isn't this cool? This is our moon phases for 2020. Now you have to change this for each year. So now what we're going to do is we're going to actually try this. I know this is a lot to try and take in because in this show, Echo Live, we don't have enough time to walk through all these. But guess what? There's a nice tutorial that a NASA scientist has done online when you download this, and they can show you exactly what I did about how to cut them out, how to assemble it, and how to use it. But let's go ahead and use it for our show today. We're going to use Stellarium. So Stellarium, again, is a free web tool that you can use, Stellarium Web. So we'll bring this up, and you'll get a chance to see it, and it'll be really cool for us to try this out in the sky. So there's one thing to be able to see the different the different moon phases that you have on here, which show you kind of its orientation, again, from above, like we saw before. But it's another thing to see it actually in the sky. So when we go to Stellarium Web, and you're using either the mobile or on the desktop, you'll get a chance to do sort of the online version. And I think you'll find it really exciting to see how it looks in the nighttime sky. So now we're in Stellarium Web, and you know what would be cool is if we could find some different constellations. So while we're here, why not, right? Let's point out the familiar connect the dot star picture, 3 stars in the handle, 4 stars in the bowl, draw a line out of the 2 stars at the edge of the bowl, Dubhe and Merak, and you can create the line to Ursa Minor's last star in the handle, which is Polaris, the North Star, Dubhe and Merak, the pointer stars. The Little Dipper points into the Big Dipper. All right, but we're not looking north for this. We're going to be looking west. So let's go along the horizon. This is incidentally called horizon astronomy. And that star that you see just after sunset is called Arcturus. It's one of the brightest stars in the sky. It's the marker star for the constellation of Boötes, the herdsman. So where's the moon? It's right there on the high. I can barely even see the moon. You know why? Because it's close to the new moon phase. It's so close that's very difficult to see. So just like we said with our diagram here, as we're looking at the different phases, we can see the new moon phase is going to be close to the sun during this particular time on the 19th of August. So it's hard for us to see it. But we're going to advance time, and we're going to click through time through each day and see as we go day by day, what do we see happen? So this is the same time each night. Look at the moon. Did you see it? Let's go back for a second in case you missed that. And look at the marker of the moon. Can we see the moon? No, it's right after sunset, close to the sun. But as we advance to the next day, you can start to see the moon's sliver, that crescent phase, as the moon goes backwards across the sky each night. Let's go again. There we go. It's about 12 degrees of arc that it travels in one 24-hour period. And that takes you around a 360 degrees if you look at each day. So let's go again. There's the moon again. And can you see it getting bigger? It's waxing, just like as you're creating candles. You can think about it like that. As you dip the candles in and out, they get bigger and bigger and bigger. So this is the waxing phase of the moon until we get to that kind of half moon, which is called the first quarter. And now we're into a gibbous phase here on the 26th of August. Can you see it there? So let's look at our moon computer again. We'll go through the new moon to the waxing crescent phase. And we'll move it again through the first quarter as we're doing here, and the waning gibbous phase, all the way to our full moon. So our full moon, according to our calendar, says September 1st. See, September 1st here. I know it's a little hard to see here. There's our full moon. It will be high overhead at midnight because the sun is on the other side of the earth. So back to Stellarium, can you see the moon? The moon is right there. It's not quite close to Jupiter and Saturn yet, but let's go through some more phases because on the 27th, you're going to see all these things lined up. A cluster of objects in space is called a conjunction. So we will have a conjunction of Saturn, Jupiter, two gas giant planets, both have rings, by the way, and the moon. So if we keep going, the 28th, the 29th, the 30th, let's keep going till we get to September 1st, and that will take us to the full moon phase. And there it is, close to the horizon, right after sunset. You should see the moon rising in the east. You can see it's going to be the southeastern part of the sky, and Jupiter and Saturn through a telescope look brilliant. So this is a wonderful thing to use. It is free, and it just says moon phases. It represents the 2020 calendar, and you can use it not only as a calendar or as a clock with the moon phases, but also as a computer, calculating from the phase that you see here what time it will be at moonrise or moonset. So you can see on either side, there's the moonrise and the moonset, and you can see these in the sky. So why don't we just see if you have any questions about what we've talked about today for our moon phases and our paper instrument part 2, learning about the moon. What would be some of your questions? Can you see the new moon? Well, I would say if you are a professional astronomer and you have a telescope that can block out the sun's light, yes, it is possible to see the new moon. But it is very difficult to see it with the naked eye because it's too close to the sun to see. So I wouldn't attempt to see it. Mercury, the closest planet to the sun, is also very difficult to see, although you can see it with a telescope with someone who is trained to use a telescope properly to make sure that they don't catch the sun's light in the telescope. But you can see Mercury at sunset, sometimes naked eye even. All right, let's see if there's another question. Is that Saturn? Yes, it was Saturn in the sky that you could see in Stellarium. And it's a great thing to look at now. As a matter of fact, I went outside to look at Saturn just a couple of days ago, and I could see the rings through a small telescope. So Saturn is a great planet to look at. Also Jupiter, as Galileo did, when he saw the first of Jupiter's biggest 4 moons revolving around the planet. Galileo was exuberant to realize that there were other objects that circled around or revolved around objects other than the Earth, when it was thought that the Earth was at the center of the universe. So these are great things that you can do. What other questions might we have here? Okay, as you're putting your questions in, I just want to say thank you. Thank you to our sponsors. This program and all of our Echo Lives are brought to you by Ford and Denso. These two companies have been longtime supporters of the Michigan Science Center. They support STEM, and most importantly, they support the STEM pipeline. Future scientists, engineers, technologists, and mathematicians that these companies employ. And we get a chance to work with their scientists and their engineers all the time on lots of different things. So I just want to thank Ford and Denso as our sponsors for this great program. We've done, this is our 89th episode. We're closing on 100 episodes. For those of you that have been here this time, we hope to do that. Let's take some last questions here. What does it look like? Can you see the new moon? I think maybe we've got most of them all. Well, I really appreciate having an opportunity to be able to have you join me today. My name is Christian, and we're here broadcasting for Echo Live. You can come and check us out during our summer schedule. As a matter of fact, we are free right now during the summer until September 6th as part of our Summer of Science. And we will be broadcasting Echo Live from Tuesdays and Thursdays at 2:30 p.m. Eastern. So we want you to check us out. So if you enjoyed this show, come back and see us again. And until next time, see you later.